beginning and end of the distributed load. Then we are completing the SF diagram. So you got the SF at left of A. Now you see how we are constructing the SF diagram. SF at left of A is 0 and SF at right of A is 15.54. You erect an ordinate there equal to 15.54. Then SF at left of C is 15.54. You erect an ordinate of 15.54 there. SF at right of C is plus 5.54. 0.54. You erect an ordinate there 0.54. Then SF at D 0.54. Then lastly SF at left of B minus 21.94. Plus means above the line, minus below the line. Now we have erected the SF at all important points. Now complete the diagram based on the variation, nature of variation of the SF. How you are deciding it? See, between A and C, no loading means SF will be a parallel line. Just join it by means of a line, straight line. Like that, between C and D, if you observe the load diagram, no load, again join it by means of a straight line. Between D and B, loading is constant, therefore SF is inclined line, one power higher than the load. Therefore, I need to join it by means of an inclined line. Yes, this completes the SF diagram partly. Some of important points in the SF diagram are the point where the SF changes its sign from positive to negative or from negative to positive. If you observe the figure, that change is occurring between D and B. Usually wherever the SF changes its sign, at that location bending moment will be either maximum or minimum within that particular location. That point we need to calculate it afterwards. Now we are going for the BM calculation. Where all we need to calculate the BMs? At point load, at start and end of the UDL, left and right of the couple. Yes, couple is not there. That is why only we need to calculate the bending moment. Where all we need to calculate it? At A, at C, at D, at B. Bending moment, whenever you are calculating it, at every moment you need to calculate it by considering the one part, either the left part or the right part. Now I want the bending moment at A. Bending moment at B. Yes, for bending moment, once again I am drawing the diagram here at the bottom. I want it at the B. Either you can take all the loads on the right part or on the left part. Yes, when I see I want it at that line, red line, that is the B. Better I am taking all the loads on the right side. Nothing is there, no load on that part. Therefore, bending moment at B equal to 0. Next is I want the SF at the point D. Friends, you can do the calculation by considering the left part of that line or right part of that line. I prefer to consider the left part. On the left part, only two concentrated loads are there. Therefore, BM at that point is, when you want the BM, you need to measure the distances from the point about which you are taking the moment. Here the point is D, you need to measure all the distances from D only. And you know, if it is upward, we are taking as positive, otherwise we are taking as negative. That is the sign convention for the bending moment. That is, sagging is positive, hogging is negative. Therefore, that 15.54, its distance from D is 2. Therefore, it is 15.54 into 2 and is positive. Next, 15 kilonewton. 15, its distance from D is 1. 15 into 1 is downward negative. That is why minus 15 into 1. The total it will become, here I have considered the right side and I got the answer as 21.96 into 1.5 minus 1.5 into 1.5 into 0.75, and I got it as 16.06 positive. Even you can do it by considering the left part. Just check the answer. Operate it on the calculator. Yes, 15.54 into 2 is plus, minus 15 into 1. Tell me the answer. Yes.
Plus 15.54.
No, 15.54 into 2 minus 15 into 1. Most probably it is 15, 16.08 or something like that. Just check it. 15.54 into 2 minus 15 into 1.
$16.08, sir.
Yes, almost you are getting the same answer. That fractional difference is there, whereas you are rounding it those numbers. Anyhow, whichever you feel convenient in the examination, that you need to adopt. Right? Next is BM at the point C. Whenever you want the BM, left and right would come only at the couple. Otherwise, at the point load, at the start and end of the UDL, you need to calculate. Now, bending moment at C I want. Again I am considering the left part. Yes, only one load is there. 15.54 into 1. The load is going up. That is why it is positive. That is plus 15.54. Last is BM at A. Yes, now definitely I am considering the left side. As such, no load is there. That is why bending moment at A equal to 0. See, in the examination, you are not telling him which part you are taking for the calculation. He wants only the number there. What is the BM or what is the SF there? That is why whichever you feel comfortable, you adopt it. Now to draw the BMD, Again the same procedure you are adopting. First you are drawing the horizontal line, zero line. You are writing the BM values at different locations, whichever are known to you. BM at B is 0 and BM at C plus 15.54. You are erecting an ordinate of 15.54 there. BM at D is 16.04, 16.06. You are erecting an ordinate there. And BM at A is 0. Now you are joining those two tips, that is A and C. Before joining you are seeing the shear force diagram. Yes, how the shear force is? That line is parallel line. Therefore, in the BM it is one order higher, that is inclined line, and we are getting inclined line. Only we need to confirm that it is not parabola or anything else. Now again you are joining between C and D. See the part of C and D in SF diagram. How it is? A line parallel to the x-axis. Parallel, here it will become inclined. You are joining it by means of an inclined line. Now coming to D and B. Yes, what is the nature of BM between D and B? For that you go for nature of SF between D and B. What is the nature of SF between D and B? It is inclined. SF itself is inclined. Therefore BM will be higher of it. Means inclined line, higher order of it is parabola. Second order. Inclined line is AX plus B, first order in X. And higher order of it is AX square plus BX or something like that, second order. It is a parabola. But what is the nature of the parabola? Second order curve. N number of second order curves I can draw. Usually to draw the second order curve line, for the straight line only 2 points are needed for me to construct the straight line. But if you want to construct the curve, minimum 3 points are needed for me. Like I have drawn there the 3 lines. One is the line, top line. Second one is the middle one. Third one is the inside one. Out of these 3, which is correct one? To judge that one, you go for the SF diagram. You check in SF diagram, anywhere the SF is changing its sign, is becoming plus to minus or minus to plus. Yes, in the part DB, SF is changing its sign. At that location, bending moment will be either maximum or minimum in the part DB. That is why first you calculate that point, mark that point. You got the 3 points. One is the point D, one more is the point B, and last one is that maximum or minimum. Just join those 3 points, you will get the curve. That is why well in advance you cannot decide which is the correct one. For that we need to go for the location of maximum bending moment as the BM between D and C, D and B it is. Whereas parabolically we need to know the maximum or minimum value of BM between D and B to trace the parabola correctly. Okay? Now that we are doing in the next part. The point of zero shear, whatever procedure I am explaining here, that you need to understand clearly. What he says is between D and B, somewhere the point of zero shear is there. That point where it is, I need to calculate it. Then there I need to calculate the bending moment, so that I will get the maximum or minimum value of the bending moment. I don't know where it is, but definitely it will be in between D and B. I can locate it by two methods. One method is universal one. For all type of loads you can apply it. Other method is particular one. That is for some specific condition only it will be applied. You after seeing it you can decide. Yes. This is what the SF diagram already you have drawn there. I am explaining it in the next page, I brought it here. Yes. That point I am calling it as the E, where the SF is becoming 0. Let that point from SF diagram, point of zero shear occurs between DB at E. That point I am calling it as the E, and it is at a distance of X from B. I am assuming it is at a distance of X from B. So to calculate where that E is, two methods are there. One is assume that the distance is X and calculate the S. If that is X, you can calculate the SF at X, at distance X. But you know the SF there at which is the point X. Wherever SF is 0, that point I am calling it as the point X or point E. So first you are calculating the SF there, and afterwards you are making it equal to 0. Yes friends, can you tell me the SF if the distance is X? There I want the SF. Yes, two loads are there. One is 21.96, one more is 15 into X, right? UDL. UDL is 15 kilonewton per meter run and is acting only per part X. Now, you are considering which part for the calculation? Just see. You are considering the right part for the calculation. Left part you have kept there only. Right part you have taken for the calculation. So 21.96 is acting up on the right part. Right is going up, therefore it is positive or negative? Yes, it is negative. Right up means left down. SF I am doing. Right up is, left up is positive. Here left is down. That is why it is minus 21.96. Now, SF due to 15 kilonewton per meter run, 15 into X is acting on the right part and is carrying the right down, means it is carrying the left up, that is why it is positive. Therefore total SF is 15 into X minus 21.96. just see here, SF at E equal to 21.96 minus 15 into X. Actually it should be 15 into X minus 21.96 and solve that equation. Why you have equated it to 0? Because you know the point E where the SF is 0. So procedure you got it or not? You are calculating the SF there and making it equal to 0. x equal to 1.464 meter. What it told is, at a distance of 1.464 meter, SF is equal to 0. This point is very important in the bending moment diagram, whether he is asking it or not. If this point is there, you need to calculate it. Okay, I got that particular point. Next, one more method is method 2. You just focus for the shear force diagram. Whatever shear force diagram is there between D and B, I am taking it out. After practice, you can do it there only. Yes, and on that I have marked the point E, I have marked the distance X. Therefore, what is the left out distance? Total dB is 1.5. Of that, EB is X. Therefore, dB is 1.5 minus X. Now, if you see, there are two triangles which are similar one. Why they are similar? The angles are same. One angle is common, alternative angle, whatever you are calling it as. And one is right angle. As two angles are same means the third angle must automatically be same. Therefore, these two triangles are similar triangles. Using the properties of similar triangles, the sides will be in proportion. Therefore, if you are considering the smaller triangle, 1.5 minus x divided by 0.54, ratio of sides, the corresponding sides are x divided by 21.96. If you solve it, again you will get the value of x is equal to 1.464 meter. Yes friends, as this happens to be the new thing in the today's session, if at all you are having any confusion in this part, please ask it. Okay, friends, now I got the point where the SF is 0. At the same point, BM will be either maximum or minimum. You calculate that maximum or minimum value of BM. How you are calculating it? Instead of x, you are taking it as 1.464 and you are calculating the bending moment. Yes, at E you calculate the bending moment. There are two loads. One is 21.96 and one more is 15 kilonewton. Now we are going for the bending moment. We need to go for bending moment sign convention. Yes, up is positive, down is negative. From E you need to measure all the distances. Therefore, first load is 21.96 multiplied by 1.464. It is acting in the upward direction. That is why it is positive. Next load is 15 into 1.464. It will act at a distance of whatever that 1.464 is there, half of it from E. If it is for 1 meter, it will act at 0.5 meter. If it is 2 meter, it will act at 1 meter. UDL's center is that total divided by 2. That is point of application of the UDL. Yes, therefore, if you calculate the bending moment, it is 21.96 into 1.464 minus 15 into 1.464 into 1.464 by 2. If you calculate it, it is just higher than 16.06. Yes, 16.07. Now you go back to the bending moment diagram. Yes, from bending moment diagram, you got the fact that at that location either it will be maximum or minimum. From the calculation, it appears that it is maximum. And actually, I got it 16.07. That won't matter there. Whatever it is greater than 16.06, slightly higher. Therefore, the first curve is the correct one here. Therefore, bottom two lines you need to remove, and correct diagram is this one here. That completes the bending moment diagram. Yes, anything confusing to you? Get it clarified. You can ask it in any language. Language should not be a barrier for your confusion. Yes, anything to ask in this particular problem?
No, sir.
Okay. Now we shall go for the next problem. As this happens to be the first problem, I took almost more than 2 hours for this particular problem. But that should not be the case for the other problems. Just see here. Prove that or show that maximum BM for simply supported beam of length L carrying UDL of intensity W per unit run is WL square by 8. This is the problem that has appeared in June 2007. Okay friends, he has asked you to prove the maximum bending moment for simply supported beam carrying UDL is WL square divided by 8. First, to draw the bending moment diagram. First you try to draw the bending moment diagram, you see what is the problem with you, then you will realize how to solve it. Okay, as per the instructions given by me, bending moment means where all you are calculating the bending moments? At left and right of couple is not there. At point loads, beginning and end of UDL. Okay, if that is the case, where all I need to calculate the BM, I need to calculate the bending moment at A, that is at point load, at B, point load, starting and end of UDL, again it is A and B. Only I need to calculate the BM at A and B and try to complete the problem. See what happens. First, anyhow, you are calculating the reactions. As it is symmetrical, the reactions are equal. For your convenience, I have taken moment about B. Directly you could have written RA equal to RB equal to WL by 2. I have taken moment about B, RA into L minus total load is W into L. Its distance from B is L divided by 2. One is anticlockwise, one is clockwise. Therefore, total moment, if you make it equal to 0, you will get Ra equal to WL by 2. And total vertical force equal to 0 if you do it. Ra plus Rb minus WL equal to 0. Ra is already known to you. You will get Rb equal to WL by 2. Now, actually SF calculation I have done. I could have avoided it. Directly BM I could have done first, and I could have explained you why I need to go for the SF. Okay, BM at A equal to 0, BM at B equal to 0. Where the BM is maximum or minimum is the problem for me to complete the BM diagram. For that again I need to go for the SF. Therefore, I am going for the SF calculations. Now coming for the SF calculations, tell me where all you are doing the SF calculations. At left and right of point load, at beginning and end of distributed load. Yes, left and right of point load means I need to calculate SF at left of A, right of A, SF at left of B, right of B. Then I need to complete the SF diagram. Actually, he has asked BM, but SF is needed for us here. Because where SF becomes 0, I need to trace out. From there, I need to calculate the BM and check whether it is minimum or maximum. Based on that one, I can give him the answer. So SF at left of A. Yes, I am considering the left part. Usually whenever I am going for SF, the procedure what I am adopting is, I will start from the left if it is simply supported. And I will move from one point to other point. Like SF at left of A is 0. Then comes the SF at right of A. See that line, red line. Yes, right of A I want means on the right side only one load is there. What was it? WL by 2. That UDL is, if you go by 1 meter, it is W. For a fraction of distance, it should not be taken into account. Whatever that small part is there, it is negligible one. That is why it will not come into the calculation. Therefore, SF is WL by 2. It is acting on the left part. Tell me whether it is plus or minus. Left up is positive. Therefore, SF at right of A equal to 0 plus WL by 2 equal to WL by 2. From there, I am going for SF at left of B. The same procedure I am adopting till right of A, WL by 2. What is new that I need to see? In the part AB, it is W into L. How it is acting? It is acting in downward direction. On which side it is acting? It is acting on the left side. Therefore, it is negative. Are you getting it? Therefore, SF at B left, already WL by 2 is there, and new entry is minus WL, will give you minus WL by 2. Yes, from there I need to go for SF at right of B. Directly you can write 0, otherwise you can check it. Till the left of B, it is minus WL by 2. and after crossing WL by 2 is coming. It is acting on what part? It is acting on the left part. Left part is going up, therefore it should be positive. Therefore already it is minus WL by 2, new entry is plus WL by 2, total equal to 0. When you are starting from 0 and living with 0 means definitely your problem is 100% correct. SF is over. Now you draw the SF diagram. Okay, BM. BM at A is 0, BM at B is 0. To complete the diagram, bending moment varies. Bending moment occurs where SF changes its sign. For that, I need to go for the SF diagram. Yes, this is what the SF diagram. SF at A, right of A plus WL by 2. SF at left of B is minus WL by 2. Join it. How to join it? See the load there. Load is constant. Therefore, SF will be one order higher. Constant, higher is linear. Therefore, it is to be joined by means of a straight line, and that straight line is definitely inclined straight line. Right? Now going for the BM, only 2 points are there. Wherever SF is becoming 0, there the BM is becoming maximum or minimum. Therefore, first I need to locate that point. Here directly using the similar triangle, you can do it. Otherwise, take a section at a distance x, calculate the SF. Whatever the similar triangle property you are using it, only the condition is that this variation should be a straight line variation. If it is a curve, you cannot use it. So from similar triangle property or from assuming the distance to L is for bending moment. From similar triangle property, you just see here, their ordinate is WL by 2 divided by x, this side triangle. That side triangle is WL by 2 L minus x. So if you simplify this equation, you will get x is equal to L by 2. What it says is, point of zero shear occurs at a distance of L by 2 from B, or the same is the distance from A. Therefore, you can calculate the maximum bending moment. As SF is 0 at x is equal to L by 2, maximum BM occurs at center. Why at the center? X is equal to L by 2, shows that it is at the center. Therefore, you calculate the maximum bending moment. Maximum bending moment. At the center, you can calculate the bending moment. See the lowermost figure. I want the bending moment here. Here the load is W per meter run for a length is equal to L by 2 and WL by 2 here. So the two loads. First load is WL by 2. It acts at a distance of L by 2. Second load is W per meter run for a length is equal to L by 2. Therefore, it is W into L by 2 is the load. It will act at the center of L by 2. That is nothing but L by 4. Therefore, the final answer will be, WL by 2 into L by 2, that is this concentrated load, minus W into L by 2 is the UDL It will act at a distance of L by 2 that is L by 4. So you totally simplify it, you will get it as WL square divided by 8. Therefore, the maximum bending moment in case of simply supported beam carrying UDL is WL square divided by 8. Yes, friends, anything to ask in this particular problem? Yes. Yes, we shall go for the next problem. Draw the SFD and BMD for the load diagram shown in the figure. Mark the values at silent points. Silent in the sense important points. Which are the important points? Point where the SF changes its sign, that is point of 0 shear. Point where BM changes its sign is called as the point of contraflexure. Point where the bending moment becomes maximum, BM max. These are the important points in the SF and BM diagram. Whether he is asking it or not, if he asks you to draw simply the SFD and BMD, you need to mark all these points. Which are those? Points of 0 shear, points of maximum bending moment, value of maximum bending moment, point where the bending moment changes its sign, plus to minus or minus to plus. That is called as the point of contraflexure. One more name for it is the point of inflection. Yes, see, this is the problem from June 2017. Here he has given you a simply supported beam with an overhang. A, B is simple support and E, B is overhang, is carrying two concentrated loads 60 kilonewton and 60 kilonewton and a couple of 120 kilonewton. Yes, first we shall calculate the reactions. Taking moment about A. Friends, you may be knowing couple is it's independent of its location. Its value is always constant as per the moment is considered. As per vertical forces is considered, its total contribution is 0. That you have studied in first year applied mechanics. Couple is a special force where it is formed by two equal and unlike parallel forces. Its value will be always constant, like the moment of a force is changing from point to point, but moment of a couple will not change. That is why I am taking the moment about the point A. I am taking all clockwise forces as 0. See what are the terms I have written there. First one is 120, it is couple, should not be multiplied with the distance, and it is anti-clockwise, that is why negative, minus 120. Go for that 60. I am taking moment from A, distance is to be measured from A only. Therefore, it is 60 into 4. It is in the clockwise direction about A. That is why it is 60 into 4 plus. Go for RB. About A, it will act in the anti-clockwise direction. That is why it is negative. RB into 2, 2, 2, totally 6. RB into 6 with negative sign. Go for this last force. 60 into 7 and is clockwise. You make the total equal to 0. Yes. You will get RP equal to 90 kilonewton. One more equation left out with us is total of vertical forces is equal to 0. So RAV minus 60 plus 90, because both 60s are in downward direction, RB is in upward direction. Make total equal to 0, you will get RAV equal to 30 kilonewton. Hence I got all the forces. Just mark them. So finally the beam will appear like this. Yes friends, now I need to go for the construction of the SF. Can you guess where all I need to calculate the SFs? As per the definition, left and right of the point load, beginning and end of the distributed load. Here distributed load is not there, only point load is there. Therefore, I need to calculate the SF at left and right of A, left and right of D, left and right of B, left and right of E. You didn't told anything in connection with the couple anyhow. I told you that couple is formed by two equal and unlike forces. Therefore, it will not come into the calculation of the SF. Okay. We shall start with the SF calculation. So, I will start from A. SF at left of A. Left of A, no forces. SF is 0. Yes, then I am going for SF at right of A. Yes, till the left of A it is 0. What is the new force there? That is 30 kilonewton. How it is acting? It is acting in the upward direction on the left part. Therefore, whether it is plus or minus, it is plus. Therefore, SF at A right is equal to 0 plus 30, that is equal to 30 kilonewton. Next, from A right, I am going to D left, SF at D left. Yes, up to A right, it is plus 30. Between A right to D left, is there any vertical load? No. Therefore, SF will not change. Therefore, it is SF at D left is equal to, already 30 is there, no change means plus 0, equal to 30 only. Then I am jumping SF at D right. D right. Yes, till D left it was 30. When you cross the D, 160 is coming. Just see on which part it is acting and how it is acting. It is acting on the left part and is acting in the downward direction. Left down means minus. It is minus 60. Therefore, it is plus 30 minus 60 equal to minus 30. From there, you are going to yes, B left, B left, SF at B left. Already minus 30 is there. Just see, is there any change in the SF or vertical force from D right to B left? No change. That is why it is minus 30 plus 0 equal to minus 30. Now from B left I am going to B right. Yes, can you guess what is the change there? Already minus 30 is there, and when you are jumping over the B, 90 kilonewton is acting in the upward direction. On what part it is acting? With respect to my line, you need to see it. With respect to my line, it is on the left side. Therefore, left up SF is positive. Therefore, minus 30 plus 90 will be the SF at B. Right, left, right. Is it okay? Now, SF at E right. SF at E right. Yes, from B left to E right. Is there any force is there? No. Therefore, to the 60, you need to add 0. SF at E left is equal to 60 plus 0 equal to 60. Last, you need to enter. You need to leave the beam. SF at E right I want. Till E left, it was plus 60. When I am coming to the E right, see what is the load acting there. 60 kilonewton is acting. On what part it is acting? It is acting on the left part. Therefore, it is minus 60. Already plus 60 is there, and minus 60 enters means plus 60 minus 60 will become 0. Like this, if you do it, effort will be minimum and you will come to know whether your calculation is right or not. Okay friends, now we have done all the calculation for the SF. We need to complete the SF diagram. First you draw the 0 line. Then you know SF at A plus 30, erect an ordinate of 30 there. Then SF at D left is 30, erect an ordinate of 30 there. Then SF at D right minus 30, erect an ordinate of minus 30 there. SF at B left, SF at B left is minus 30, erect an ordinate of minus 30 there. SF at B right, it is plus 60, erect an ordinate of plus 60 there. SF at E left, plus 60, erect an ordinate of plus 60 there. Now I need to join all these points. From A left, I am coming for A right. From A right, I am going to D left. Now see the load between A to D. No load. That is why SF will be a parallel line. Then from D right to B left, see the load there. No load. That is why I need to join it by means of a straight line, parallel line. Again, B right to E left, no load. Yes, this is what your required shear force diagram. Here you are having the 2 points where the SF is changing from positive to negative or negative to positive. On one side of that point it is positive, on the other side of it is negative. Therefore, this point is the point of zero shear. Only where it is changing, that we need to specify, not the zero values like A and E, because these values at the corresponding locations, either the bending moment will be maximum or minimum. Therefore, that is very important for us. That is the point of zero shear. Yes, this completes our shear force diagram. 6 minutes is there, rather than again starting tomorrow the same thing. Couple is there, I will explain it tomorrow only. Yes friends, any doubt till now, unmute the mic and ask me the clarifications.